Hello everyone, welcome back. Today we're going to be talking about the practical application of 20 MOA scope mounts. Okay, I've got an example over here. If you look on this rifle, on the scope over here, you'll see it says 20 MOA. Okay, um, so before we get into that, we kind of need to understand how first focal plane scopes with high magnifications work. Okay, so if as you zoom in, the entire reticle gets enlarged. Okay, so you're zooming in not just on target, but also on the reticle. So over here to the left, right, I have an image of a reticle, right, and let's say I'm at, if I was, let's say at on that scope over there, the lowest is 5 magnification. So if I was at 5 magnification, I would be able to see, if you look at these numbers over here, these are mil lines, you would be able to see all the way down to 15, okay? But when you zoom in, right, and then you're zooming in on the target and on the reticle, as the reticle enlarges, okay, I can no longer see all the way down to 15 mils. Because everything's getting bigger and enlarging, the lowest I can see is 8 mils, okay? And then over here, if I zoom up all the way to let's say 25 power, as you zoom in this example over here, the most I can see is 4 mils. So everything that's below here is out of the field of view of my reticle, okay? So that's generally how it works with these first focal plane scopes that have high magnification. So if you're shooting long distance, what you want to be able to do is spot impacts and make corrections. Okay? So if I'm holding just on the reticle, right? So let's say at if I'm shooting 500 yards, okay, right? If I'm shooting 500 yards, my hold is usually 3 mils over here, right? But let's say I guess it. So normally, let's say if I'm just holding on the reticle, and I got a 50-yard zero, instead of putting the chevron here on a target, I'd be putting this 3 line here, okay, for 500 yards. But let's say I'm wrong, right? And instead of it being 500 yards, it's actually 700 yards, right? So I'm holding on the reticle for what I think is 500 yards, and because I've miscalculated the distance, the splashes that I'm seeing in the scope are going to end up someplace down here, right? Because I'm going to end up hitting low because my holdover isn't enough. So because they're going to be someplace down here, I'm never going to see them. I'm never going to be able to correct. So ideally, if I'm shooting at distance, and I think I'm going to be, and I think that my holdover for 500 yards is 3 mils, rather than holding on the reticle, what I want to do is I want to dial up on the turret 3 mils, okay? So by dialing up on the turret 3 mils, okay, now instead of holding on the reticle at the number 3, I'm actually going to hold the chevron point right there. So I'm going to put that underneath my target, and what's going to happen is if I guessed my target correctly at 500 yards, I should hit it. But let's say I'm wrong and the distance was actually 700 yards. What I'm going to see is I'm going to see a splash down here. So let's say I see a splash on the 3 line, right? Because I guessed the distance wrong. Well, once I see the splash here on this line over here, I'm going to take this point here, move that up to the target, and take my shot. Okay, so that's the reason why we dial up with with these type of scopes that have high magnification. We don't want to be holding on the reticle, okay? We want to be holding on the center aiming point of the reticle, so that if we guess the distance wrong, we can spot the impacts someplace down here and see corrections. If I don't do that, if I don't dial up, and let's say I'm holding on here, if the splash is someplace down here below my my field of view, I'm not going to see it. I'm not going to see the correction. Okay, so that's the reason why when we're shooting at distance, we generally dial up. That's not something that we're going to do in LPVO, right? Like LPVO, usually it's a set and forget. I'll get my 50-yard zero, and I just use the reticle However, for this, I'm generally not really shooting past, past 600 yards. And with 5.56, what generally happens is, like when I had that out to 800 yards, the 5.56, even though it'll get there, especially with a 77 grain bullet, what happens is, since that magnification only goes up to 10 power, I have a really hard time spotting the splashes, okay? So I can't make corrections with the 5.56 and only a 10 power. So that's why on this AR-10, okay, I use a 308, which is going to make a bigger splash at 800 yards, and I use a higher magnification, although a lot of times I may only just go up to 10 power. But the combination of the two, more magnification and a bigger splash, I'm able to see the splashes and make corrections. Okay. So now we're going to talk about the 20 MOA scope and how that's useful for this. So we're dialing here. We're not holding on the reticle with this type of a scope. So if you've got like this scope over here, this is the primary arms 5 to 25 by 56. This has 30 mils of travel. Okay, it's got 30 mils of travel. So what that means is that's what I would call the mechanical zero, right? That's the halfway point. So if I get a 50-yard zero, it's going to be somewhere around the halfway point. So what that means is I only have 15. I can only dial up 15 mils. I'm not using the top half. Okay. So I only got 15 mils to work with. So the way that works is if I'm shooting 1,000 yards, and I've done videos where I'm shooting 1,000 yards, if I'm using a fast ammunition like I was using, I'm using a relatively fast ammunition at 1,000 yards. My dial up is 12 mils. Okay, so if you notice, the max I have to work with is 15 mils, and I'm dialing up 12 mils. I only got 3 more mils to go. So if I were to use, let's say, a slower bullet, let's say a heavier bullet, right, like a 168 grain bullet instead of like a 147 grain bullet, dialing up 12 mils would not be enough. I don't know exactly what it would be, but I might need to dial up 16 mils, okay, or 17 mils. But I only got 15 mils to travel, okay? So by using a 20 MOA scope, right, what that does is it shifts my 50-yard zero up here, and it gives me about 5 extra mils of travel. So now, with a 20 MOA scope, instead of having just 15 mils of travel, I now have 20 mils of travel. Okay, so that will allow me to use a slower bullet or to go out the further distance, go out to maybe 1,200 yards. Okay. Now, if I use a 25 MOA scope, instead of giving me 5 extra mils of travel, that's going to give me 7 extra mils of travel. Okay, so now instead of having 15 or 20, I'm going to have, that comes out to like 22 mils of travel. Okay, and if I use a 30 MOA, that's going to give me an additional 9 mils of travel. So that's lot more dialing up that I'm able to do if I'm using either a heavier bullet or if I'm shooting at further distances and I need to dial up a lot more on the scope. Okay. Now with a scope like this one over here has 30 mils of travel, but you might, let's say you have a cheaper scope, right? Let's say your scope only has a total of 40 mils of travel. Okay. Actually not 40, that's MOA, but let's say you have a scope that instead of having 30 mils of travel only has 20 mils of travel. Okay. So if you only got 20 mils of travel, now you only got 10 mils to work with over here. So you absolutely need those 5 extra mils. So you're definitely going to want to use a 20 MOA scope. Now, my thoughts are that all scopes, like including, let's say I got this Aerial Precision mount over here. Okay, this is a 0 MOA, right? Which means that I think this has like a total of 40 mils of travel. So the halfway point would be 20. So if I were to use the turns to dial, I only got 20 mils up, 20 mils down. Okay, so with the 0 MOA scope, that's all I get. It would make sense for, let's say, Aerial Precision to make all their scopes 20 MOA because it doesn't hurt me in any way. Okay, I'm not losing anything. And even though this is not a scope that I'm going to dial up on, right? And the reason why I don't want to dial up on this scope is because it doesn't have a zero stop. And the problem is that when you start dialing up and you go, it's very easy to lose track. Because with this one, if I start rotating this, and especially if I go make a full rotation, it's very easy to kind of forget where you are. Okay, did I come all the way back around, or especially if you go, so it's really easy to forget where you are. This scope over here has a zero stop, so with this, I can rotate this back and forth, okay, and I'm gonna spin this back down, right, and it's always gonna get me back to my 50-yard zero because I'm able to set the turret like that, right? So I can dial up, dial down, boom, I got a 50-yard zero. If I'm going to be shooting, let's say 1,000 yards with this, I know I got to make a full rotation, go to, let's say 12 mils up, okay, and then when I'm done shooting, I come all the way down. So that's only something that I do with scopes that have a zero stop. If they don't have a zero stop, I'm generally just holding on the turret. I'm generally using a scope that has less magnification because this one only goes up to 10. So what that means is that when it's in 10 power, I can actually see the full reticle. It's not out of my field of view. With this one over here, when I get up, like, if I go past 10 magnification on this, a lot of the reticle is outside of my field of view. So I need to dial up so that when I'm zoomed in on the reticle, I have someplace down here where I can spot the impacts, right? So even at 1,000 yards, I want to be using the tip of the chevron here, not trying to hold someplace down here where it's, if I see if there's any splashes, might be built outside of my field of view. Okay, so that's why on a scope like this where you're dialing up, you always want to have a 20 MOA mount. You don't lose anything. It just gives you the ability to add more travel, right? So instead of using the mechanical halfway point for your 50-yard zero, your 100-yard zero, you get to use the upper portion of your turrets. Now, it sometimes gets a little confusing because even on mil scopes, a lot of times we're talking about MOA mounts. Okay, so over here I've got a scope that's in mils, but I got a 20 MOA mount. That's just an issue of like centimeters versus inches. Okay, 1 mil is 3.4 MOA. 2 mils is double that. 3 mils is triple that. Okay, so you're just multiplying and dividing back and forth by 3.4. So it doesn't matter if the mounts are quoted in MOA of 20 MOA, 25 MOA, or 30 MOA. Again, you're just dividing back and forth by 3.4 to get from mils to MOA. Okay, but that's the practical application of an MOA mount, right? That gives you either 20, 25, or 30. You're trying to get access to the top portion of travel on your turrets, which is normally not used. Okay. And the reason why you want to get it is because you're shooting at distance, right? And you don't want to be holding on the reticle when you're shooting at distance and zoomed in. You want to be holding on your chevron or your central aiming point or whatever you got, so that you can spot the splashes down here, inside of your field of view. Because as you zoom in, the reticle, you also, as you zoom in on the target with a first focal plane scope, you're also zooming in on the reticle. And when on that scope, for example, when I'm zoomed in, I can't see the 7, 8, I can't see these numbers down here. I can only see, let's say 1, 2, 3, 4. Actually, I can see up to about 6, but this is just an example. As you zoom in, if that was, let's say, if that magnification on that scope went up to, let's say, 30 magnification, it would stop at the 4 or maybe at the 3. Okay, so that's how that works. So that's the benefit of a 20 MOA mount, and I think that they should make all mounts 20 MOA because it's not hurting you. So let's say on this one over here from Aerial Precision, which is a 0 MOA, even though I don't dial on this, it would have been nice if this was 20 MOA, because down the road I might switch scopes. I might decide to put a different scope in there that I do want to dial. Okay, so if you've got a choice, right? If you're buying a scope and the option is 20 MOA or 0 MOA, you know, if they're about the same price, get the 20 MOA, because down the road you might be able to use that scope, that mount with a different scope. Okay, so it gives you options. I just got this one. I wanted to get a 20 MOA for this. I actually got it. The issue that I had is it wasn't long enough, and this scope here, this GLX, this is the 1-to-10 GLX. It's got a lot of, you know, basically there's a large distance here, and I needed to push this a lot further up, and I couldn't find a scope in the, like, up, you know, in the price range I was looking for, of about $60, that I could push this far forward. That was 20 MOA, you know, and $60. So that's why I ended up going with this 0 MOA from Aerial Precision. But now you understand the practical application of the 20 MOA mount. So if you got any questions, drop them in the comments. This is, you know, this can be a little complex, and if I need to, I'll do another video in the future, talk about it some more. Okay, talk to you all soon.